So dear friends, my name is Sheikh Hussain. This is the fourth video. In this video, we are going to discuss the chemical properties of two most important organic compounds. They are ethanol and ethanoic acid. So first we will discuss about the chemical properties of ethanol. So what is ethanol and what is this formula? C2H5OH, or it can also be written as CH3CH2OH. In general, commonly it is also called as alcohol. Let's see what are the uses of alcohol. And alcohol is a good organic solvent, and the important property of ethyl alcohol is, even though ethyl alcohol is an organic compound, non-polar compound, it also dissolves in polar compounds like water, because it is due to the presence of intermolecular hydrogen bonding. Ethyl alcohol is used in most of the medicines, in the preparation of medicines. Tincture of iodine, it is used to prepare cough syrups, tonics. It is also used as fuel, and it acts as a anti-freezing agent, and it is soluble in water due to intermolecular hydrogen bonding. And consumption of alcohol causes some dizziness. Doctors suggest that consumption of alcohol, even to a little extent, is not at all good for health. In all over the world, per annum, 2.6 million people are dying due to alcohol consumption. Per day, nearly 7,123 people are dying per day due to alcohol consumption. So alcohol consumption is not at all good for health. Next we will move on to with reactions of ethanol. Here only there are two reactions. One is ethanol reaction with sodium metal, and ethanol on reaction with concentrated sulfuric acid. When ethanol reacts with sodium metal, what happens we'll see. When ethanol CH3CH2OH reacts with sodium metal, sodium is a highly reactive metal. We know in our activity series and all we have studied, and it displaces hydrogen from ethanol. This hydrogen atom displaced by sodium metal. When this hydrogen is displaced by sodium metal, then we'll get a CH3CH2O Na. In the place of H, we got Na. And what happened to this hydrogen? This hydrogen releases in the form of hydrogen gas. That means when ethanol reacts with sodium metal, active metal, and hydrogen gas will be released. Simultaneously, a salt will be formed. Name of this salt is sodium ethoxide. Sodium ethoxide. See here, I'll write CH3CH2O. This is called ethoxide. This is ethyl and oxygen. This is called ethoxide. Ethoxide. When it combines with sodium, it becomes sodium ethoxide. Sodium ethoxide. Why we are writing name sodium ethoxide, not ethoxide sodium? This is because while naming a salt, while naming a compound, first we have to name the cation, then anion. So for example, NaCl, sodium chloride. How will name this compound? Na plus Cl minus. Cationic name, then anionic name, sodium chloride. Similarly, in sodium ethoxide, CH3CH2O minus and Na plus. So it's a cationic part is sodium. So sodium should be written first, followed by ethyl and oxygen called ethoxide, sodium ethoxide. So sodium ethoxide one salt will get, and simultaneously hydrogen gas will be released. Next, second reaction of ethanol with concentrated sulfuric acid at the temperature 443 Kelvin. When ethanol is heated with concentrated sulfuric acid at 443 Kelvin, and it loses water molecule. Concentrated sulfuric acid is a dehydrating agent. Dehydrating agent means it removes water from the compounds. So here how the water molecule will be removed? So here CH2OH is there, no? This OH, and in CH3 one of the hydrogens will be removed. If we remove one hydrogen from this carbon and OH from the second carbon, what we get? Here one hydrogen is removed, so this becomes a CH2. This becomes CH2, and at second carbon we have removed this part OH and CH2 plus H2O. Water will be removed. So it is called dehydrating agent. So name of this compound, here two carbons are there. So eth, and number of hydrogens are double to the number of carbon atoms. 2 carbons and 4 hydrogens. That means C2H4. can also be written as C2H4. Two carbons eth and hydrogens are double, so it belongs to alkene family, so it is ethene. This can also be written as CH2 double bond CH2, or can also be written as C2H4. The same reaction you can also write like this, C2H5OH. Suppose if you write like this, and it will be easy for you in the exam, H2SO4 at 443 Kelvin temperature. Just you remove one hydrogen from here, hydrogen and OH. Then what we get? C2. Out of 5 hydrogens, 1 hydrogen we have removed, so 4 hydrogens will be left, plus, and this hydrogen and this OH both combines to give water molecule. C2H4 will get, C2H4 is nothing but ethene. You can write the same reaction in this way, and it looks little simple in comparison with the previous representation. Second compound, ethanoic acid. Ethanoic acid formula CH3COOH, CH3COOH, or it can also be written as CH3C double bond OH. But in most of the cases, in general purpose, we follow this formula only, CH3COOH. Commonly it is called as acetic acid. Acetic acid. And its common name is acetic acid. Actually, this is IUPAC name, scientific name is ethanoic acid. And 5 to 8% ethanoic acid is called vinegar. 5 to 8% ethanoic acid is also called as vinegar. In cold climate, acetic acid freezes very quickly and it becomes solid and it solidifies. So it is called a glacial acetic acid. At even lower temperatures, it solidifies, and so it is called glacial acetic acid. It is a weak acid. Remember, that means it does not undergo complete ionization. For example, if a hydrochloric acid is dissolved in water, it completely dissociates into H plus and Cl minus ions. Whereas acetic acid, CH3COOH, when it dissolved in water, it doesn't undergo complete ionization. For example, it ionizes as CH3COO minus and a H plus. It splits into CH3COO minus and H plus ions. Remember this structure and it will be helpful in the coming reactions. Okay, but it doesn't undergo complete ionization. For example, if you take some 100 molecules of this, out of 100 molecules, some 5 molecules or 2 molecules will undergo ionization, or maximum some 10% you can say. Remaining 90 molecules will be in undissociated form. So simply, acetic acid is a weak acid. It does not undergo complete ionization, which is a weak electrolyte. Now come to chemical reactions of acetic acid. The first chemical reaction, we have total 4 chemical reactions here given in our textbook. Esterification reaction, saponification reaction, reaction with base, and reaction with carbonates and hydrogen carbonates. First, let's start with the esterification reaction. What is esterification reaction? Esterification reaction is nothing but a formation of esters. It's a reaction in which esters are formed. So esters are very much helpful, and they are sweet smelling, and they are used to prepare perfumes, and they can be used to prepare artificial flavoring agents. You might know what are artificial flavoring agents. Generally, we drink some soft drinks like Maaza or orange juice or appy like that, but actually the real fruit will not be there in those juices. Just artificial flavoring agents will be added, and those flavors makes us feel of a real fruit. Right? Come to the reaction. CH3COOH, that is acetic acid, reacts with C2H5OH. What is C2H5OH? Ethanol. Ethanoic acid combines with ethanol, will get some product. What is the product? We'll see here. And to understand this reaction easily, just have a ionic form of this two compounds, CH3COO minus and H plus. Here I am not going for exact mechanism of the reaction. Just to make you understand, I am taking some ionic forms of these two compounds, CH3COO minus and H plus, and this C2H5OH can be taken as C2H5 plus and OH minus. Here what happens, the cation of the first compound combines with the anion of the second compound and vice versa. So for example, this H plus combines with OH minus here. Whenever H plus combines with OH minus, what we get? We get water, H2O. H2O having two ions, H plus and OH minus. We'll get H2O. That's over. And what left? The CH3COO minus and a C2H5 plus. These two opposite ions combined together. So what we get? CH3COO and C2H5. This is the product, main product. What is the name of this compound? The name of this compound is CH3COO minus and C2H5 plus. The name of C2H5 plus is ethyl. And the name of the remaining part, CH3COO, is acetate. So name of this compound is ethyl acetate. Why we should write ethyl first followed by acetate? Just few minutes back I told you, whenever we are naming the compound, first we have to write the name of the cation and then anion. So cation here is ethyl group. So ethyl, and the remaining part CH3COO minus is called acetate. So ethyl acetate. So ethyl acetate is also called ester. So ester's general formula is RCOOR. This COO is the functional group for esters that you will study in higher classes. R and R. Here two alkyl groups are CH3 and C2H5. This is called methyl and this is called ethyl. All these details you will learn in higher classes. So when ester is formed, just we discussed what are the uses of esters. Esters are sweet smelling, use it to prepare perfumes, use it to prepare flavoring agents. Okay, next chemical property is a saponification reaction. Saponification reaction means preparation of soaps. Right? How soaps are prepared? Very simple. When esters are treated with strong bases like sodium hydroxide, potassium hydroxide, we'll get soaps. But actual reaction we are not discussing here. The basic rule or basic principle in the saponification we'll discuss. Here we have taken some ester. What is its name? Ethyl acetate. Just we discussed. When ethyl acetate reacts with strong base sodium hydroxide, we'll get product. What product we get? So to understand the product, just make these compounds in ionic form. CH3COO minus and C2H5 plus. NaOH can be taken as Na plus and OH minus. So here C2H5 plus combines with OH minus. C2H5 plus combines with OH minus, opposite ions. So we get C2H5OH. This is ethanol or ethyl alcohol. Ethanol we get. Next, remaining part CH3COO minus combines with Na plus. CH3COO minus combines with Na plus. So we'll get CH3COO Na. It is a salt. Sodium acetate. Its name is sodium acetate. Just a few minutes back I told you CH3COO minus is called acetate. This is sodium. While writing the name, first we have to write the cation, then anion. Sodium acetate will be formed. Actually, this is the simplest form of soaps, and later in the coming video we will discuss what is the actual formula of soap and all. The sodium salt of higher fatty acids. Soaps are nothing but sodium salt of higher fatty acids or potassium salts of higher fatty acids. That means soaps are nothing but some salts of higher fatty acids. We come to the third reaction, reaction with bases. In the beginning, I told you acetic acid is a weak acid. It's a weak acid, weak electrolyte. It can also, even though it is a weak acid, since it is having acidic nature, it reacts with bases, even strong bases or weak bases. Here we will discuss with the strong base NaOH. To understand this reaction, again we will go for ionic form CH3COO minus and H plus. If you study in this way, you can easily understand the reaction. And Na plus, NaOH, Na plus and OH minus. Here CH3COO minus combines with Na plus. CH3COO minus anion combines with this cation Na plus, will get CH3COO Na plus. H plus combines with OH minus. When H plus combines with OH minus, we'll get H2O, water. And what's the name of this compound? CH3COO minus Na plus. Just in the previous reaction also we have seen. This is called acetate, this is sodium. First we have to write the name of the cation, sodium. So sodium and acetate, sodium acetate, it is a salt and water. And this one is weak acid, and this is a base, and here we got sodium acetate, salt, and this is water. Do you remember anything from this reaction? In the chapter, second chapter, acids and bases, you might have studied about neutralization reaction. What is neutralization reaction? It is a reaction between an acid and base to give salt and water. So this is also an example for neutralization reaction. Acetic acid reacts with sodium hydroxide, gives sodium acetate and water. Next, let's move on to the last reaction. Reaction of acetic acid with carbonates and hydrogen carbonates. Right? Acetic acid CH3COOH plus Na2CO3, sodium carbonate. So metal carbonate, and here metal hydrogen carbonate, sodium hydrogen carbonate. It is also called sodium bicarbonate. You may observe here we have taken 2 moles of acetic acid, here 1 mole of acetic acid. Here actually the number of moles of acetic acid we took depends on the number of sodium atoms in these reactants. See here 2 sodium atoms, Na2CO3, so we have to take 2 moles. In this way you can remember the stoichiometry of the reaction, means balancing of the reaction. Here 1 sodium is there, so 1 acetic acid molecule we have taken. That's all, very simple. Now Na2CO3, so we have to take 2 moles of acetic acid, 2 CH3COOH, Na2CO3. And again we'll follow the ionization method, ionic method. So CH3COO minus H plus, Na plus, CO3 minus 2, actually it is minus 2, 2 Na plus, 2 sodium ions are there. What happens? This CH3COO minus combines with Na, will get CH3COO Na. Actually how many moles are there? 2 moles, no? Here 2 moles of sodium and 2 sodiums, and here 2 moles of acetic acid, so 2 can be taken common. 2 CH3COO Na plus what is left? Here 2 hydrogens, this 2 is common, no? This 2 is common for all. So how many hydrogen ions are there here? 2 hydrogen ions. These 2 hydrogen ions combines with 1 oxygen. Actually how many oxygens are there here? How many oxygens are there in CO3? There are 3 oxygens, no? Out of 3 oxygens you take 1 oxygen and combine with these 2 hydrogens, then you get H2O, water molecule. And since 1 oxygen we given to hydrogen atoms, how many oxygens are left here? 2 oxygens are left. So carbon and 2 oxygens, and it becomes carbon dioxide. Carbon dioxide gas will be released. That means when acetic acid reacts with sodium carbonate or metal carbonates, carbon dioxide gas will be released. Similar reaction you have studied in the chapter acid, bases and salts. Next come to the second reaction, CH3COO minus CH3COOH NaHCO3, CH3COO minus and H plus, and this is Na plus HCO3 minus. It's very simple. CH3COO minus combines with Na plus and will get CH3COO Na, sodium acetate, and what is left? 1 hydrogen here and 1 more hydrogen here, 2 hydrogens, and you take 1 oxygen from CO3 and 2 hydrogens, 1 oxygen becomes H2O, just like the previous reaction. And since 1 oxygen we have given to 2 hydrogen atoms and 2 oxygens will be left, then it becomes CO2. Here also carbon dioxide gas will be released. That means when acetic acid reacts with metal carbonates or metal hydrogen carbonates, carbon dioxide gas will be released. These are the 4 different chemical properties given in our syllabus of ethanoic acid. So just go through these reactions. Don't by heart the reactions. Try to understand the reactions so that you can remember for longer time. Be healthy and be happy, and we will meet in the next video. Thank you.